Design a task scheduler which schedules tasks for a company. The task can be scheduled using regex. The load of the system is very high.
So first thing is I want to start with what all functionalities will be provided here.
Okay.
So basically, we uh, system should accept task with the time of execution,
Okay.
and if we schedule a task for a time, the task can be scheduled using check. Okay, the load on the system is high. Okay. Do we need to have any provision of canceling the submitted task?
Let's not worry about it for now.
So for now, we will be just submitting the task, and it will with the time of execution, and at
Hmm.
the mentioned time, system
Hmm.
should execute it.
Yeah, and it can not. It so there can be two types of tasks. Basically, one thing which is for meant for only one time execution. One which is for like using the
Repetitive.
regex, like which is repeated like a cron job.
Okay.
Said
One-time task or repeated task with regex.
yes.
So we cannot cancel it. Once the task is executed, we should notify it. Do we want to have the notification as well?
So you can probably like the user should be able to see the status of the job which he has actually done. Like what was the if suppose a job is there and they are it is having last 10 schedules, right? He should be able to query those schedules, what happens, and suppose whatever you are doing in that task,
Mhm.
whatever logs and all are there, that he should be able to do. That tracking system should be there.
Okay. Track the status.
User in this case is your client. Okay.
Track the status of the submitted task.
Hmm. Status and we can enhance it with time, right? It can be anything.
Okay, so for now, it is for tracking the status. So what went, if anything went wrong and task failed, then we should that status should be uh, visible to the client,
Hmm.
right? So I think this is this the enough for now? This much functionality.
Yeah, go ahead. That's fine.
So let me write some non uh, functional requirement.
Sure.
System should scale as we have discussed. Load is high, so scalability, high scalability, highly scalable.
Mm-hmm.
Should be available.
Yes.
Okay. What else? Uh, System should not miss anything. Like whatever task is submitted to it, it should execute at the required time. Right.
Yes.
Okay.
What do we call that?
It should be like correct in its functionality.
Reliable, right?
Yeah, should be reliable. Okay. So yeah. So what do you want? I mean, should I start with the block level diagram or with the tables or what all?
Yeah. So in this case, I'll give you a tip. If the interviewer doesn't tell you anything, right, you can go ahead and try. So how you approach a HLD interview is that if you are given a problem, you are expected to ask a lot of questions, okay? And then you should be able to actually give in your thought process, be it very loud and clear, give your thought process, and then start. Wherever the interviewer requires, right? They will ask you to deep dive into a certain aspect. So
Okay.
until unless the interviewer is not asking you, you should be able to go ahead and actually like go ahead and take it at your own pace. Okay.
Okay.
So you could go with the whiteboard and start basically designing how it would be. Good.
Okay. So yeah.
Yes.
So what I'm thinking is there will be one client.
Okay.
Let me try it. Client will be sending the request, and the request will be taken up. Uh, Request will be first sent by the client to a queue. We can consider it as a Kafka queue.
Okay.
Actually, I'm not well versed with this. So it will be sent to a Kafka queue.
Mm-hmm.
Should I pick it?
If you want to use any other tool, you can also use that and share your screen.
Okay, let me just draw a rectangular. I'll mark it as a queue.
No issues.
So it is kind of a topic or queue where the request will be placed,
Okay.
and after that there will be a listener of that queue, which will be our system that will be start processing it.
Mm-hmm. Mm-hmm.
I'm not sure why it's not coming. I need to select it. So from where our system will pick it up. So what I am trying to do is all the requests will
Mm-hmm.
be present in the queue, and
No, but only one client or there are multiple clients,
there can be any number of clients.
and all of them will be sending it to this topic.
Yeah.
So will, as you said, Kafka.
Yeah.
So how would you scale it?
So
Because what's your plan? Like, can you go more deep in that? Like, how, why you are choosing Kafka here? I want to know. And like, suppose like depending upon number of jobs that you are getting, right, to be scheduled. I think you should ask that number, right? So that will give you more reasoning, and and
number of
then you
number
then
of
you
jobs.
should jobs that you are expecting every minute. Okay.
Okay. Okay.
Okay, accordingly, and you can you tell more deep like why you are using our topic here, like why Kafka
Yeah. So
and how you use Kafka.
the thought process here is since Kafka is a kind of distributed store which store the data in a distributed fashion, so we can scale it up very easily. We can increase the number of brokers, and even also it's also like we can have the message sequenced as per the client. Like if we send a message with a particular client ID as a key, that
Hmm.
message will always go to a single partition. So if you want to have something like ordering of messages, also ordering of tasks, that also we can do on a client basis.
So one thing I want to know will like how many topics will be there in your Kafka and how will that look like?
So we can have few topics like on the basis of priority we can have some low priority task or some high priority task. So on the basis of that we
Okay.
can
Who
create
is deciding the priority here?
so uh, I think that can be decided by the client itself if the client want to send uh, it on a higher priority or a lower priority. But uh, let me think on that.
Yeah, yeah, take your time. No issues.
Hmm, I think every client will want their message to be a high priority, right? So it's not good to be decided by client.
Mm-hmm.
Uh, Rather, what we can do is we can have a few queues that or topics that dedicated to each client, but it will, I think, it will like if there are a million of clients, it will just outburst the number of queues.
So, are you expecting? So, you can take a assumption here that overall the load is very high, but for a particular client, the load is will be limited. Okay,
Okay.
like a single. First of all, just tell me one thing.
Mhm.
How is this client communicating with this topic? Like, client can be anything, right? Are you providing a UI where someone is coming and scheduling a job, or what's the mode of communication between your client and this topic? How is that communication looking?
So yeah, we can have a service on top of that, which will be validating the client, and if the client is, I mean, authenticated, then that service will send the data to that particular topic.
What do you mean by a service?
We can have a microservice in between.
Okay, then how will your architecture look like?
Yeah, let me shift it a little bit. It can be, there can be a front end service which will be taking the request, and from this will be sending it to a Kafka topic. So we can have something like that. So yeah, I was thinking on Kafka topic. Let's assume that uh, yeah, you told that client for a particular client the load will not be much high. However, the overall
Hmm.
system it can be there can be many number of clients, right?
Yeah, I can say that there's some that is a valid assumption which you can make.
Okay. Okay. So there can be some tasks that can be scheduled. Okay. So I was thinking to how many topics we can have. We have a front-end service that is acting as an intermediate layer between the client and topic. And uh, if we want, we can also have priorities decided by this service, and there can be multiple queue based on the priority.
Can we focus more on the execution part first? That let's not worry about the priorities for now.
Okay. So once the message is put by the front-end service to Kafka topic,
Mm-hmm.
that will be picked by another service, uh, which will be actually executing and scheduling that task.
Can you complete your architecture?
Yeah.
Then I have a lot of questions.
Okay. So This message will be picked up, and there can be task scheduling service. This service will be uh, sending the data, this I mean task to another data store where it will store.
Can you move it to the left? Actually, I'm not, okay. No, no, it's fine. I'll do it. Yeah,
Okay,
go
so
ahead.
it will be
Huh.
sending this task to a data store with the uh, task detail and the time of execution. If it is a one-time execution, it will directly execute it. Otherwise, it will store it in a data store.
No, but okay. Which type of data store you means is a database, right?
Yeah, yeah.
So which database are you using here?
We can have mm, RDBMS where we can store the task along with the time of execution,
Okay.
and there can be another service which will be kind of executing. Uh, I mean, checking every minute whether there is any list of tasks for which the execution time is. I mean, the clock has struck the time
Can
at which.
you
Uh,
can you go on more detail that how will that part maintain? Like you are saying there can be different service, right?
mhm.
Which will be checking that is there any other task which is to be scheduled at that time, right?
Yeah.
So like how is that working internally? Like and what is the exact so I didn't get till now like why you need to first tell me why you are using Kafka. How how is your client mapped to a topic? Then
Mhm.
what I understand is task scheduling service is a Kafka consumer,
Yeah.
right? So you
Yeah.
will have one service or you will have multiple services.
Yeah.
How you are actually taking care of your highly available, right?
Yeah.
And yeah, I also want to know like see what I want is like more data whenever we are putting any kind of blocks, right?
Mhm.
Let's try to give a clear reasoning for them like and how will this work like these are high level things okay I'll have a database and I'll have a Kafka and all but how will it actually work like if suppose you have to onboard a new client
Mhm.
right is there something change you will do in your Kafka getting my point right
Yeah. Yeah. I'm getting it.
because if you are doing that change and if that change is actually seamless then your reasoning for Kafka is right
Mhm.
just putting it without any reasoning is not correct.
Yeah. So the reason that I thought of is the front end service need not to wait for this service to either schedule it or put it in
Mhm.
DB for at the later time to get it scheduled. Its
Mhm.
main task is just to put it in the Kafka topic and then it is done so that it can receive the any other request at a particular time and it won't be blocked like right. So
But in your case, so okay, one more thing I want to ask is this front-end service is a single point of failure, right?
no, it can be scaled.
How will you do that?
It is like a kind of microservice which will be scaled and it will be accepting client request
Will
and
it be accepting client request directly or how?
it will be kind of HTTP endpoint.
Okay, okay. But how will you manage your load if you have multiple front end? Are you talking about vertical scaling here?
No, it can be horizontally scaled.
But will the client node will directly interact with the
The,
but
no, there will
uh,
be API gateway in between
okay,
and that will be kind of load balancing as well.
okay, fine.
So after that, front-end service will be kind of just its task is just to receive the task and put it in the Kafka topic, and it will be free to receive the next request. Now the task scheduling service will be picking the request from Kafka topic, and it will check if that task needs to be executed at that point, one-time task.
Yeah, that's where I want to know. So first of all, let's. I am very much clear now. Like client will be talking to an API gateway.
Yeah,
API gateway will be distributing your load to a multiple front-end service, which are nothing but a microservices running, right?
yeah, yeah.
And there can be services running. I think, I guess, for your like tracking part, or for your scheduling part, or any kind of updates, right? There can be multiple microservices which will be there. Let's worry about only the scheduling for now.
Yeah.
Then for a client, will there be, which topic will the data go to? How will you determine that? What is your bare minimum things you require from the client? Can you write it down?
Okay.
Like how, what information will client set? How will it goes to Kafka? And like I am not clear to that picture. Like, and how this task scheduling service will interact with Kafka. See, what I'm trying to tell you is, let's try to go more deep,
Okay.
right? Like
Okay.
on a code level, how will it work?
Okay. Okay. So you want that how will the data, what data will be sent and how will it flow, right? Right. This is what we want to discuss.
Yeah. So what I want is that how you will be, yeah, how that flow will be here. You can probably tell what kind of services you will be actually, like what data will go from the client and how it will come to Kafka.
Okay. So yeah, let me go to this. There, the task that client will be executing, will be requesting, can be. Uh, should I write it in this or right here itself?
You can write using that text right above the client. There is a there. You can use that and write here, right?
Okay. So yeah, basically the first thing that comes to my mind is what can be the task that client needs to execute. Will it be a kind of a code that it want to execute or a script or something like that? So if if the client is uh, let's say the client want to execute a script, so we want that script as well somewhere by the client, right?
Why we are going with the script here? It's a microservice, right?
So I'm just trying to think that what can be the task that client can execute, that client can request for this service to get executed, right? It can be. Do we have any limitation on that, or it can be anything like it can be a script, it can be a Dockerized container jar that it want to execute.
Uh, let's think that it's up to you. How do you design that interface? Like, okay, that's a good question. That what kind of task is can be scheduled. So I think you take that the client is giving some instructions, right?
Mm-hmm.
And those instructions basically you are taking it as a like that you need to decide. See, like how you will take those instructions, and then as per that instructions you will be actually uh, with that instructions you will be actually like executing the task.
Okay. So okay. So the client is giving. Let's say the client is giving the instruction where it contains the task name and how it what it want to execute and at what time, right? So as a part of what it want to execute, it can be uh, something like that it needs to provide as well to the our system, right? So that can be placed in some shared data store. Like let's say if it is a Docker image, then client needs to create the image and provide the name of the image. Right, that's what I am assuming. And if you want anything else, then we can go with that
No,
also.
chalo, let's go ahead. That is fine. Then How will that topic be decided? Or will there be one topic across all your architecture? How it would be?
Okay. So yeah, I was thinking that only. So let's say there are multiple clients and all want this that their task needs to be executed. Okay. So on the basis of what tasks we are trying to execute, we can have different topics, right? Like if the client wants a Docker image, so we can have a uh, Docker queue
For
connect.
simplicity, let's first worry about there is only one type of task.
Okay.
It's a new system. It is actually supporting just a file and running it as a shell script. Nothing else
Okay.
for now.
Okay.
Don't worry about Docker and all those complexities. I'm trying to like keep it fixed.
Okay. Okay. So the queue can contain the task related data, and what we can do is mm, there can be one approach that comes to my mind at this point in time, like mm, related to the priority that I have earlier told. But I'm just thinking, uh, would it fit here? Do we actually need it or not? Because every client will want, like, if any client is asking for scheduling a task, there need not to be a priority. Right? So it will always be at a high priority. Everyone want their task to be executed at the mentioned time. So okay, one thing that we can do is we can have one queue for scheduled task, which is going to be scheduled later, and one queue for a task that is going to run. That is a kind of one-time job. So on the basis of that, we will have a different listener. One will be only scheduling it, storing it in a data
But
store.
what about your one-time jobs which are for a future time, right? Matlab, I'm just trying
Yeah.
to understand if there is a job which is to be scheduled every 5 minutes.
Mm-hmm.
Okay, suppose it is 12 o'clock, and you submit a job which is to be scheduled every fifth minute of an hour. Basically, 12 5, 105, 205, 305, 405, right?
Mm-hmm. Yeah.
Versus a job which is to be scheduled once at 12:05. What is the difference between these two? Matlab, that's where like how you will store in your data store, right?
Yeah. Yeah.
So that is where. So did you decide like for a client there will be a topic, or how it would be? Like each client will have their own separate topic, or what are the benefits of like how do you scale your Kafka?
So I think there is no need to have different topic for each client because each client won't be the load, as we discussed, that the load for each client won't be high. So if we create each topic for different client, it will not make sense.
Okay,
Rather, we can make a single topic that will contain all the detail of the client, and we can have client key as a client ID as a key in that, so that in that topic, whatever message we are sending, so that it can go in a ordered fashion.
so in Kafka, is there any limit on the number of partitions you can have for a topic?
I'm not sure about that, but I think we can have as high number of partition as we want. That depends on the number of broker also.
But there will be a but there will be actually like, so what is a good way of scaling? It is via one topic and multiple partitions, or multiple topic with multiple partitions, and what is the benefit of that? Like I'm just asking
Yeah,
you a question. Like if you have two topics, right,
yeah,
and with multiple partitions,
yeah.
and you have one topic with multiple partitions, so and your load is very high. That is given, right?
Hmm.
So which one you will take? Like how will your task scheduling service work and how you can scale?
Yeah, so uh, actually increasing the number of topic is good, but there should be some criteria on the basis of which we
No, no,
can
I'm not
replace it.
saying that. I'm just asking if we have multiple topics, okay, with
Mm-hmm.
partitions, and I have one topic with partition,
Mm-hmm.
then how will the scaling work in both the cases? You can just tell me that.
Okay. So if we have one topic with multiple partition, so we can have as many number of consumer as the number of partition. So in the starting, we can decide a very large number of partition,
Mm-hmm.
and on the basis of that, initially we can have lesser number of consumer than the number of partition, and when the load increases, we can increase the number of consumer on that. So this is when we have a single topic with multiple partition.
Okay.
Now, when we have a multiple topic with
Hmm.
multiple partition,
Hmm.
so since there are I mean, let's suppose that if there are two topic, then uh, the number of consumer that can work on those topic will be doubled, right? So let's say one topic has 10 partition. Now we are creating two topic with 10 partition each. So now we can have 20 consumers. In the initial first approach, we can have only 10 consumer at max.
So in which case do we create multiple topics, and in which case we have only one topic?
I think that depends on the functional aspect, that what data we want that topic to contain. If
Mm-hmm.
there is any functional segregation, like there are different type of consumer that are doing different functionality for a different type of data, then we can have different topics
Hmm.
so that different consumer can act in a different way. So if but if the consumer are acting in a different way, I mean in the same way, then there is no sense of making different topic, and both the consumer are, I mean, working in the same way.
Right. Go ahead. Yeah. Now, how will your task scheduler service work? Suppose there is only one topic, which is having large number of partitions, right? So,
Yeah.
how will you scale your task scheduling service, and how is this task scheduling service listening to Kafka? Like, like consumer, right? It's a consumer which you have started. So, is it polling again and again how it is actually listening and what is happening?
Yeah, it's a consumer, and how Kafka consumer, if we are using Kafka, so Kafka consumer works by polling. So it there are some configured time that we can give to it. So it will start polling at that after each configured time interval.
Mm-hmm.
They will bring in the message that is present, and they can start working on that.
So, what will this exact responsibility of this task scheduling service will be?
Yeah, that I'm coming to that. So this service, what it can do is, just give me a second.
Take your time.
Yeah, so there can be some one-time task that can be required to be executed at that time or at a later point in time. There can be some repeated tasks. Okay, so that task service, what it can do is, it will be just checking it, uh, right. So this will be just checking uh, from the Kafka topic that what is the type of task that it is getting, and if it is a kind of, let's say, repeated task. So here I think a different approach came to my mind, that we can have a different,
Hmm.
we can have a different table, one for repeated task, one for one time task, so that the lookup
No,
will
no.
be
What is this task scheduling service doing actually?
yeah, yeah, I'm coming to that. This service is just taking up the task from the Kafka topic and storing it in a database. Well, and if it is a the task is going to be executed at the same time,
Mm-hmm.
then it will be uh, now. Should we give the responsibility of executing the task to this service? That I'm thinking. The first task that it will be doing is for sure picking up the task from Kafka topic and putting it in the database, or if that task is going to be executed at that point in time. So I'm thinking that should we give the responsibility of executing to this service, or should we offload it to some other service?
Can you first think like how will you store it? Because see, now we are clearly a client, there are multiple clients which are interacting to API gateway, which is coming to
Yeah,
microservice,
yeah,
which is going to Kafka. You have one topic which you explained with multiple partitions, right?
yeah,
Now you have multiple task schedulers, which all are part of one consumer group. I'm assuming
yeah.
they will be different consumer group,
They will be part of one consumer.
one consumer group, right? So they will break out the partition between themselves,
Yeah,
right?
yeah.
Now what they get the data from the Kafka topic partition.
Mhm.
So now what they do is dependent on your data schema, database schema, right?
Yeah, yeah,
And now you told that you will be using a RDBMS, right?
yeah.
So can you think for like how will your data store look like?
Okay.
How will you plan to store your data? Then how will the real execution look like? And all those updation, everything, how will it work?
Okay.
Because we should ideally run the task at the time it is really asked, right?
Yeah, yeah. So we can have one table. We want to. I'm going to write down the table, right?
Yeah, yeah. If you can just give me high level, like, or like, just give me good overview of like how you plan to store your task and everything.
There can be task ID. There can be task name, client ID, which client has requested it, and the URL. Let's say URL of the task. Uh, let's say we are storing the task in a separate store. It can be either S3 or
Yeah, that is fine. That you are actually just taking a URL here
yeah,
and you're storing that file somewhere else where someone will go and actually
pick it.
do those part. That is fine.
Okay, so the URL of the task is here. This and the time of execution also. And if it is going to be a one-time task or a repeated task, we can have I mean, a column which is a kind of uh, which can take the type of task. So it can take a value
This is
that
a task table, right?
yeah,
Okay. Then how will your like how will your service know like okay if it is
yeah,
1209 which all tasks to be
executed, right.
done? How will you know that part?
Yeah, so
Well, it is a very highly scale system. Load is very high.
yeah, okay. So what we can do is there can be approach where this service, let's assume that there's a different service as of now, which is holding the responsibility of executing the task.
Which service?
There is a service which is having this is the task execution service.
Okay.
So this service is the holding the responsibility of executing the task. So one approach can be this needs to go to the database poll every 1 minute, or let's say, but here there will be a chance like if that task the time is I mean expired, like the task needs to be executed at T1 and this service uh, can. start polling at T1 plus 30 seconds, then uh, it won't be able to execute at the mentioned time, right? So if you are going to use
Yeah.
the
So basically, what I really want is this task execution service, right? Which
yeah.
it is there. Then it is a single point of failure, right?
Mm, Not exactly. It can also scale up, but
But if you are scaling, then how will you be? How you are making sure that
yeah,
your task is not executed twice?
yeah. That thing just came to my mind. Like there can be a scenario when if we scale up, then both the service will pick the same data, right?
Yeah.
Okay. So what we can do is we can again introduce the queue here. The first thing that comes to my mind is we can again introduce a queue. The service uh, that the dispatcher service can be here, which will be just dispatching the required task. Uh, it will be polling this data store every one like 30 seconds, and it will be dispatching it to another Kafka queue. From that Kafka queue, this task execution service will pick it up. Right.
But what will the dispatching service do now?
It needs to again the I am having the same logic like it needs not to uh, spend much time on executing. Its only task is
Okay.
to
Let's see one thing for a queue, right?
yeah.
How many or a topic? How many topics will you have in a topic for be like for 1 minute there will be one topic or how you are planning?
No, the topic will be one only. But the point that
Hmm.
I'm coming is this service again will be a single point of failure, and we can scale it up. But in that case, we need to take a lock on DB so that
No, no, no. Tell me one thing. If it is 1208 currently, right?
yeah.
And you suppose you have to your lowest amount of time unit. I think that should have been a question to be asked to the interviewer. Is that do I need to schedule a task at each millisecond level, at each minute level, nanosecond level, or it is at a like minute, hour, or second, right?
Okay.
Okay, what is the like the minimum time unit?
Okay.
So let's take it as a minute. Okay,
Okay.
suppose it is 1208.
Mhm.
So at 1209 your
Mhm.
this task execution service come up. What will be there in the queue?
Okay. So in the queue, there will be all the tasks that are required to be executed at any point in time.
Any point of time at 1209.
Yeah, at that particular point in time.
But
Like 12.
how are you doing that computation again and again, right? Because now it is 1209, then at 1209 you should put for 12010 also, right?
Yeah.
So how will you make sure?
So the question is that okay, as the time changes, how we make sure that that all the data for that particular time is available in the queue.
Yeah, and it is a very highly scale is very high.
Okay. So the issue here can be. Just give me some second. I need to think on that.
Take your time.
If we are going to put it in Kafka queue, this dispatching service will be running every, let's say, 30 seconds. It is going to pull it, put it in the Kafka topic. Execution service will be picking it up, and will it make sure? Hmm. Uh, I think there will be some issue here. I now I want to
Mm-hmm.
use something like a concept of delay queue, where the task that is placed, it needs to be that queue should not allow the task to be popped up until the time has I mean that destined time is occurred. So something like Redis will most suited here. It by default provide a delay queue concept where we can store the task, and it will allow the task to be stayed with the Redis until that particular time has reached, kind of a delay queue.
But that is store everything in memory, right? How you handle a persistence part there.
No, this service will be storing in the Redis. There is a persistence layer still here. This dispatching service will be picking it up from here, and it will be. Uh, then what is the? Just give me some more second.
No issues.
The data store. We are going to store it here, and at that time the dispatching service will pick it up. What is the need of this then? It can. So I think there is no need of this service as a whole. We can use data store for a persistence kind of functionality, which can be
Okay.
any RDBMS,
Mm-hmm.
and at the same time we can store it into Redis, on which the task execution service will be acting upon. So it needs to check. Uh, but what if Redis fail? Basically, what I want to use is a kind of delay queue so that task execution service need not to run through everything. It can be handled implicitly by the delay queue. So
Why? What is the reasoning behind what is the delay queue will do?
delay queue will store the message, and it will allow the consumer to fetch it only at the particular point in time when the message needs to be executed, right? So that functionality will be handled by delay queue itself, and the service need not to go and pull the DB again and again, and it since it can take time, right? So
So, okay.
yeah, I want to store it to the Redis and data store at the same time, and task execution service will
But
pick it up from the Redis.
tell me one thing. How much data will you be storing in your Redis? Like, if suppose today is time T, right?
Mhm.
Like, will you be, and we can schedule the jobs for a year max, right? Let's take that assumption. So,
Yeah.
which all jobs you will be storing in your Redis? Will you be storing all the jobs in your Redis and also in data store? How it would be?
Okay. Yeah.
Because see, when the thing which is actually the point which you are missing here is the task is having a schedule, right?
Yeah.
If it, a task is a single task, this is one schedule. If a task is having multiple tasks, if it is a recurring one, it has multiple schedule, right? This task scheduling service is saving a task, but it also need to compute those schedules, right?
Yeah.
You need to make a distinction here, like how do you store that schedule? If it is a nearby schedule, then store it in both Redis in your data store, or if it is a future schedule, store it only in a data store. Now, as our scale is very high, then how this Redis get backfilled? Like if there is a schedule which was for 1 year later, but when that 1 year is coming, how will it come back to the Redis, right?
Mm. Yeah.
And then how will your see that part is right that you are creating a queue scaling, but what is a blocker happening is like how you will store it in your data store. right?
Yes, yeah.
So you are coming with the end of the part. That's why I'm trying to tell more.
Okay.
So that's how this is. So yeah,
Okay. So we can have a service which will be should be given the task to backfill the.
you could have think in that way. Like, have you worked on NoSQL DB?
Yeah. A little bit only, not much.
Yeah, so what you can do is you can have a partition based upon the time, right? And what you can do is like this task scheduler service, right? You first need to decide that like how much time data you are keeping in the like next 5 minutes, right? There
Mm-hmm.
can be data that you can keep in the Redis, right? And then for each one, like you can keep it in the different partition, which is for the nearby, maybe for a day, right? And others you can keep in a normal RDBMS. So accordingly, what will happen is you would be able to, and then your this dispatching service needs to poll it every time and see if it is coming from your that one day partition. Then it will do the backfill part. And this scheduling service you need to do. So here the main thing was like how will you decide your data store? Okay. How do you decide your tables? That will actually see because the scale is very high, right?
Yeah.
So, how efficient that system will be, how fast it would be, and when we are not missing any schedule, right?
Yeah.
That's how it would be.
Okay.
Okay.
So we need to have a NoSQL where the sharding will be on the basis of time,
Yeah,
right?
we can use a combination of a NoSQL
Okay.
and like if we are using NoSQL, then there is also a concept of why to use a like NoSQL with the Kafka, everything is in overkill also. But yeah, we can use an RDBMS also, but we need to have clearly that okay, which holds a data for a particular day, right? We can create those kind of tables. We can create a table which is a main table and a schedule for a day.
Okay. So there
Okay,
needs to be a service that needs to fill that schedule for a day table, right?
that your task scheduling service will do, right? Task scheduling service should ideally take the data from the Kafka from what I got. It's need to compute all the schedules. See, okay, this schedule is later, store here. This schedule is latest, store in Redis also, stored in this part in RDBMS also. That logic should go to a task scheduling service.
And also it needs to keep on checking every day that I mean every hour or every after
That
2 hours.
thing dispatching service will do, which
Yeah.
will pull the DB, check that particular single table, and new task it needs to give to the task execution service.
Yeah.
So the dispatching service should also not go down.
Yeah. But that again needs to take a lock on DB, right? So that it should not uh, multiple instance should not pick the same task and put it in
Yes,
try to
yes.
put it in DB.
Yeah. That's why instead of using a queue, what we could have done is we could have just taken a we could have so what you are saying is basically you are saying if it is a data and the data is basically there for a day, how you are filling that your Redis part here, right?
Yeah.
If there are multiple consumers which are listening there,
No, the dispatcher service itself is running in a multiple instance of the service is running, right? So that it won't
but
be
do
a
we really need multiple instance?
so that it won't become a single point of failure, right?
In that case.
In that case, there can be a chance like two service uh, fix the same data and try to put it in the Redis.
That where we need to manage those lock.
Try to put it in the Redis. Or optimistic locking or
Yes.
something like that needs to be done there.
Yeah. So I think we are. I'm done actually.
Mhm.
So you have any questions? Obviously, whatever you want, I whatever I know, I will be able to answer it.
First of all, it would be good if you give me a consolidated feedback from the beginning. How should I
Yeah.
change my
So
approach?
okay. So the point of writing those functional and non-functional requirements was good. Apart from that, what I really feel is that that you also like boil down to a set of requirements which was fine,
Mhm.
right?
Yeah.
And later on you started, but yeah, I think that you could have asked more clarifying questions. Otherwise well, we are moving along with the discussion on those NFRs. like on the time unit part or like this part. And one more thing I like to tell, if you're making any assumptions, please call it out. So if the interviewer is actually having a different thing, he can clarify then and there. And then the biggest,
Just sorry to disturb. For this scenario, can you highlight where should I have called out my assumptions?
uh, like you were assuming, like in this scenario, like there can be different type of tasks, like Docker
Okay.
and all this thing. We were going in that direction, which is altogether a very good functionality, but maybe the interviewer is not looking for that.
Okay.
My main focus for the interview was how you will manage this data store execution, you not missing schedule. I was not really worried about what kind of task it is.
Okay. Okay.
So that thing, one thing, and also major thing what I found is that your overall design looks good, but whenever you are putting a block, you are not confident giving the reasoning part, like why Kafka,
Mhm.
and I had to push you a lot to go more deep, right?
So I should have
Yeah, yeah.
proactively explained it earlier.
Yes, yes, that will give you good brownie points.
Okay.
That otherwise it will look like okay, the person has just read it and put it, being very frank. So
Okay.
that is one part which you take care. Rest, I think your concepts are fine, but only the delivery, right? I'll tell you, be more confident, ask questions, and see. And also, it also depends upon the interviewer. He's technical or what he is looking forward to. So it's always good to take it according to the interviewer. Like if they are focusing to more on microservices, they someone would have asked to write a microservice to you also. Maybe they want to test your dead skill. Maybe like it is a bigger problem, right? There are multiple facets to it. In whatever part he is focusing, we could have actually deep down to that. Okay.
Okay. When you say I should have written the microservice, means I can write the code when
I'm
it is
not
required.
saying that I am asked. You should have written down, but there could be an interviewer which would have asked you, okay, what what will be the endpoint for your service,
API. Okay. Right.
which your client would be calling to test your microservice, like how do you name it, or what will be the response code, or all will there be any kind of server side caching, anything, right? There are different aspects to it. It's a very big problem, right?
Okay.
And in a 40-50 minutes interview, you cannot focus on everything. So they will actually pick an area, go more deep in that. So what
Mhm.
I'm trying to tell you, whenever you are making any design choice, like okay, data store, you should tell RDBMS, tell some kind of tables. If you're taking Kafka main thing is that how many topics. So those things will give like okay, you know the internals of Kafka. Okay.
Okay. Okay.
So
So, do you have any feedback on the number of topic that I have suggested?
I think that reasoning came late, but the reasoning was fine as per me.
Okay. Okay. And other than that, uh, so yeah, I have one more question. Like, I started with functional, non-functional requirement. Then I decided to move on to that block diagram.
Hmm.
Should I ask the interviewer that whether I want to move to block diagram first, or he or she want me to explain about the API, DB tables, and other things?
Yeah, it's always good to clarify, but yeah, HLD is mostly about block diagrams. So it depends from interview to interview. I like to more see the overall architecture, how it is working, and then
Mm-hmm.
I like to ask the design choices. I like to see if the person is able to boil down to the lowest level of details. Then I like to see like whatever NFRs they have written, right? How is their architecture having those points? Like if you said highly available,
Complying to that.
how is it highly available? If you are saying reliable, how you are ensuring the reliability? Then
Yeah.
I say, okay, is it actually like fulfilling all your functional? Like here, analytics we didn't discuss because we didn't have time.
Yeah.
How will you maintain the data for analytics and all? Those part was also there.
Mm-hmm.
Okay.
And I have one more question.
Yeah, no issues.
So when we talk about reliability, so that's when I think that delayed queue should be there. Otherwise, there can be a chance that we miss some task by a time gap of some
Yeah,
seconds.
that is fine. At least that we called out was fine. I think we can leave the problem now. Let's talk about generic system design things like how to.
Yeah, yeah.
Overall, I felt fine. Just whatever improvement points are there, I have told you. Okay.
Okay. So yeah.
So consider that there is